Give me something. All right. Are we ready?
No.
Okay, so we're going to do something else today. So basically what we're going to do today is combine two different things that we know how to do. Kimberly, we good? All right. So we know how to solve simultaneous equations, yes? So what are the two methods of, well, actually there are three methods. Okay. Substitution, elimination. What's the third one? The one we don't like that takes a lot of time.
That's trial and error. Guessing.
I've just taught it to the grade 9s.
Google it.
Not Googling.
Reading.
Oh my goodness. It's the graphical method, guys. Oh, there it is. All right. So it's where you literally draw the two graphs and see where they intersect, right? Yeah, we hate it, right? It's not very precise. It is essentially an approximation. Unless it's a perfect thing, we don't like it. That's why we don't do it. So we are going to learn to solve simultaneous equations today, but one of them is going to be quadratic, right? So we've only ever done it with linear stuff. I promise it's not that hard. It's literally the same process. It's just that one of the things is a quadratic instead. Why is that so high? All right, so let's have a look at doing that. We are going to use these two methods only. You will be glad to hear. We don't like that method. It takes time and it is an approximation, so we don't like it. Okay, if someone did draw you a graph, what would you be looking for if you were asked for solutions? No. You're looking for points of intersection. If you had a quadratic and a linear, how many points of intersection might you get? Are you sure? Definitely wrong. Ah, very good. It could be 1, 2, or 0. So if you have a quadratic that looks like this and a linear that looks like that, you've got 0 points of intersection. If you have something that looks like, oh geez, let's pretend they touch. You have something that looks like that, you've got 1 point of intersection or 2 points of intersection, okay? So how would we know? Actually, let's talk about that in a minute. All right, stop it. Boom. All right, so let's look at two different equations. So our first equation is going to be y equals x squared minus 3x minus 1. And our second equation is going to be y equals 2x minus 7. Okay, the easiest way to do this, which, yep, I'm going to use substitution. I'm going to say y is 2x minus 7. So I'm just going to put them together and say 2x minus 7 equals x squared minus 3x minus 1. Now I'm going to make it equal 0. So how many x squareds do I have? X squared. What about my x's? 1. Minus 5. So we're bringing this across as a negative and then positive 6, right? Because this is plus 7 minus 1. It's just a quadratic. See, it's not that hard. Can I factorize this? Yeah. So what am I factorizing bits? So my x solutions are 2 and 3. Am I done? Why not? Good. I need to put this back in to get my y coordinates. These are my x solutions. Correct. So this means there are 2 different points of intersection. So I'm going to put this into 1 or 2. Right. It doesn't matter, but 2 is easier, isn't it? Let's do 2 because it's easier, but it does not matter. So y is, so that means that coordinate is going to be 2, negative 3, and then y equals 2 times 3 minus 7, which is negative 1. So the second coordinate is 3, negative 1. So if we graphed these, so let's actually do that. Okay, I'm just going to show you that this is what actually, oh, this is not being recorded, is it? Let me just share my, oh, if I share, hang on, okay. Oh my goodness, you people are the worst. Oh no. People are the worst. No video. Can't even mock my own accent. That's not cool. All right. So y equals 2x minus 7. That was the first line. And the second one we had is y equals x. Where's my little square thing? Square. Oh, what? So x squared minus 3x minus 1. So can you see those 2 points of intersection? Do they match what we said? Look at that. That is 2, -3, and that is 3, -1. Yay. Oh, thank you. Thank you. All right. It is very. Back to meeting, please. Okay, stop sharing. Okay, let's go back to our whiteboard, and nothing's going to be there, I think. Yeah, we're going to have to start again. Right. Let's do it again. All right, guys. All right, let's do it again. So we're going to look at y equals x squared minus 2x minus 1. And our second equation this time is going to be y equals x minus, whoops, sorry, blah, 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 x minus 5. All right, let's do the exact same thing, right? So instead of y, I'm going to substitute what y equals. So then I get x minus 5 equals x squared minus 2x minus 1. So 0 equals what? Minus 3x. Okay, what do I do from here? Okay, so what's my...
So equations are 4 and minus 4. X minus 4. Yes. X is 1.
No, it's not.
No.
Does that work? That doesn't work. So what is it?
X minus.
There's no solution. That's why no one can think of it. And Caleb, if I wanted to use the quadratic formula, that does. So how do we know? What did we learn last lesson? How do we determine if there are any real solutions? Any real roots? Discriminant. So remember, b squared minus 4ac. Let's try it, see what happens. -3 squared minus 4ac. This is 9 minus 16.
Yes, it's less than 0.
It's less than 0. So that means there are no solutions. So this graph is going to look something like that. No. Okay. Oh, jeez. Caleb and I are going to figure out ways to torture you all later. All right. So that's sometimes 12:30. All right. So if there is no solution, just check your discriminant to make sure that you're not missing something. But if your discriminant is less than 0, there are actually no solutions. All right, we're going to do one more and we're going to solve it in a different way.
So if the discriminant is 0,
It's got one repeated root, right? So both of them. So what I'm going to do is I'm going to solve this one in a different way, but it's going to be the same idea. So let me just give you another example. So, whoa. So I've got y squared. This is going to be my first one. This time we're doing y. So y squared plus xy plus 4x equals 7. This is in a very weird format, so you're not going to be able to do what we did before. My second equation is going to be x minus y equals 3. I'm still going to do substitution, okay? I'm going to rearrange this to say x equals 3 plus y. But what I'm going to do is I am going to put this in place of both of these x's. Right? It's not going to be as complicated as it looks. I promise it's not that bad. It just looks a little different, but it's still substitution. So y squared plus 3 plus y, plus 4, 3 plus y. And then I'm going to say minus 7 equals 0, right? I'm going to bring all this across. This will be a normal quadratic once I finish with it. So I've got y squared, distribute.
3y plus y squared.
Oh my goodness.
Minus 7. so that brings you to.
Oh, I hate you so much.
Y squared,
Yep.
plus 7y, plus 5.
All right. Now, this is something we can factor. We've got 2y and we've got y. The good thing is we know the numbers are 5 and 1 because they're the only options to multiply to 5. Okay, are they we've got both positives as well. Now, all I have to do is figure out what goes where. Okay, I think that works as well. Well done. So what are my solutions? -5/2. Again, just like before, I need to substitute this back into this to get my x values, all right? So that means x equals 3 minus 1. So x is just 2. So one coordinate is going to be 2, -1. And then, then the next one is 3 minus 5 on 2. So what do I get? It's not 1.5. Boo. 2.5.
0, 1,
We're leaving it in fractions. So then I get half and -5 on 2. All right. So my two different solutions to this. Actually, let's use a different color. Oh my gosh. All right. So those are my 2 points of intersection. All right. So, all right, guys. I'm going to kill someone. All right. For now, head up, buddy. All right. So all we're doing is simultaneous equations where one of them is a quadratic. Usually we're just using substitution, right? Make them equal each other, or if you need to do something like this and sub it back in because you've got 2 letters, a little more complex, but exactly the same thing. Once you get your x coordinates or your y, put it back into any of the original ones to get your other one, to get your other coordinates. I mean, the elimination method is going to make your life very difficult and does not always work. Yeah, so it's much easier just to use this one. Sometimes it could be appropriate, but generally speaking, no.